Hey everyone, so today we are going to be going over the limit comparison test. Alright, so let's look at what I have written down here. So the limit as n approaches infinity of an over bn. This is the standard formula for the limit comparison test. Alright, and right next to this we have to prove convergence. This is what needs to be satisfied here. The limit as n approaches infinity needs to be a positive finite number, and also bn must converge. All right, so now let's get into this first example to see what this all means. All right, the series from 0 to infinity of n over n squared plus 3. All right, so first what we want to do, we need to make sure that we can use a comparison test here, either the direct or limit comparison test. And after analyzing this, yes, we can. All right, first what we need to do is find our bn. And how we do this, we need to make a judicious bn, all right? And how we do this is we look at the highest power in the numerator and the denominator, all right? So this 3 goes to nothing, all right? We only look at the highest power in the numerator and denominator. We got 1 up here and I got 2 down here. So we put both of them, we put the n on top, we leave the n on top and leave the n squared on the bottom, all right? And we would have n over n squared. And this would lead to a bn of 1 over n, just like that, okay? And now our an would stay the same, right? It's just n over n squared plus 3, okay? And now let's see if we can use a direct comparison test here, all right? And we can't really tell what's bigger, what's smaller, so we don't know. Therefore, we use the limit comparison test, all right? Limit as n approaches infinity, all right? an over bn, so our an is n over n squared plus 3 times, we're going to flip the bn, all right? n over 1, just like that, because we're dividing. Now this is the limit as n approaches infinity of n squared all over n squared plus 3, all right? And now let's use L'Hopital's rule or whatever to find this limit, and our answer would be 1, all right? Now, to prove convergence, our limit needs to be a positive finite number. 1 is that. 1 is that, all right? However, we got to look at bn now. So, does bn converge or diverge? 1 over n is the harmonic series, which always diverges, okay? And now since that fails, this whole series diverges, all right? Diverges because bn is harmonic. Just like that, all right? Now, our next example we have here is n squared plus 5 all over n to the 4th plus 3n, okay? And now, what we do here, let's analyze it, all right? This looks like a comparison problem, all right? Because we got a power on the top with something that goes to nothing, another power on the bottom with something else that goes to nothing, okay? So now, using the limit comparison test, all right? Well, not even using the limit comparison test yet. To pick a judicious bn, all right, we look at the highest power on the top and the bottom, okay? And just be n squared all over n to the 4th, which would just lead to 1 over n squared. So that's our bn right here, okay? And now our an would be the same thing, n squared plus 5 all over n to the 4th plus 3n. And is always going to be the same as what the regular series, as the original series is, okay? And now are we able to use the direct comparison test here? No, I don't think so, all right? It's too complicated, too hard, all right? We don't know. Therefore, we're going to use the limit comparison test now, all right? The limit as n approaches infinity of n squared plus 5 all over n to the 4th plus 3n times n squared over 1. Again, I just flipped the bn because we're dividing it, All right. Now this results in n to the fourth plus 5n squared all over n to the fourth plus 3n. Solving this limit, use whatever you want. We get 1, which is a positive finite number. That's good. All right. However, we got to look at the second condition for convergence. All right. Is our Bn convergent? Okay. Is the Bn convergent? So 1 over n squared. All right. This is a p series. All right. With p equal to 2, which is greater than 1. Therefore, that converges. Okay. So this is our Bn right here. It converges. Therefore, everything converges, all right? The whole series converges because our first condition is satisfied. The limit is a positive finite number. And then also our Bn is convergent. Therefore, the entire series converges. And that is the limit comparison test for you. Thanks for watching.